All right, so solving literal equations is exactly the same, literally, as solving any equation. Okay, we group our like terms, we simplify our expression and get our x equal to or y equal to. So in both cases, we're trying to solve for x. So step one might be to bring my kx across, equal, and let's take minus ny minus z across onto the other side. Now I've got two representations of x there. If it was a 3x minus 2x, we just do 3 minus 2. So we do exactly the same thing here. X is common to both of those terms, and we have m minus k. I might just take the negative 1 out the front, and that gives me an ny plus z. Just get rid of all those negatives. And now if I want to get x on its own, I divide both sides by m minus k. And so now we've got an expression for x. So the only thing, if you think about the math that we've done, it's all relatively straightforward, confusing because there's no numbers there. And we don't enjoy that typically. All right, let's have a look at number two. Number two does look a lot messier. We've got fractions. So the simplest way to work with fractions typically is to get a common denominator. So what if we concentrate on the left-hand side? So let's think this through. If this was 3/4 minus 2/5, we sort of get a common denominator by multiplying both top and bottom by 5, multiplying top and bottom by 4. So if we have a look here, we get 5 times 3, that multiplies that multiplies that over a product at the bottom. So in here, I'm going to get p times m plus x minus x times 2m all over the product of the two. We get 3y on x. So let's simplify the left-hand side a bit first. So expand and group terms if we can. So we've got pm plus xp minus 2xm all over m plus x with x at the front. Alright, so I'm thinking from there, let's get rid of those denominators a little bit. So what if again we multiply both sides by the denominator? So let's multiply that x across to the left hand side, so I get x at the front of pm plus xp minus 2xm. And we'll multiply the 3y with the times x m plus x squared. I'll just multiply that through. So now at least I've got rid of my denominators. It makes life a little bit nicer, I think. Let's expand. Pmx plus x squared p minus 2x squared m is equal to 3xmy plus 3x squared y. Alright, so let's just keep plodding along. Let's group everything onto the left-hand side. So we'll have an x squared p minus 2x squared m minus 3x squared y plus xpm minus 3xmy equals 0. So it looks to me as if all of those have got an x in them. Well, let's group the terms together. We've got a lot of x squareds there. So let's go x squared, and we get p minus 2m minus 3y plus an x m is common. Actually, I might leave the m in there since it's all about getting x on its own. Right, pm minus 3my all equal to 0. So we can take an x out the front now, and I get x outside the front of p minus 2m plus, minus 3y plus Pm minus 3my equals 0. So we've got our null factor law there. So possibly x is equal to 0 is theoretically a solution, but if we have a look at up our equation there, x can't be 0 because it's in the denominator. And then that leaves me with x p minus 2m minus 3y plus pm minus 3my. So let's take one term across. Now I might take that m out the front. All right, is p minus 3y over p minus 2m minus 3y. Very ugly looking answer. So x cannot be equal to 0, so x is equal to, let's just highlight that in a different colour. Quite a messy sort of answer there. Obviously we could solve the same thing on our CAS, but yeah, interesting question.